In this lesson, we're going to look at proving trig identities. Now, it's expected you know these two trig identities in National 5, and then it's a case of using them to help you prove trig identities that are given to you in questions. It's also handy to know some rearrangements, but I did go over this in the last lesson. Right, let's get to it. So an identity basically is a rule that can be proven to be true for any value of x that you substitute in. So this should work here, this green one. It should work for any value of x. Then if you put in tan 40, that should be the same as sine 40 over cos 40. Same idea here. If you put in sine squared 40 plus cos squared 40, you should get 1 popping out. Any value of x it should work for. Now, to prove an identity, there's a technique that you use. Generally speaking, you start with the left-hand side of the equal sign. You play a mess about with it and eventually try and show it's equal to the right-hand side. Now, the idea of messing about with it mathematically is usually using multiplying out brackets, factorising, substitution. These are the general techniques that we try and use. Right, let's have a go at it then. So, the first example here, we're trying to prove that 2 sine squared x plus 2 cos squared x is equal to 2. Now, when I'm talking about the left-hand side, I'm talking about the left-hand side of the equal sign, which is here. And when I'm talking about the right-hand side, the 2 is the right-hand side of the equal sign. So we generally start with the left-hand side. So you write it out, which is that. It's the left-hand side of the equal sign. And again, you mess about with it to try and get to the right-hand side. Now, the first thing I'm going to do here is I'm going to isolate the 2. I can see a 2 is common to both bits, so I'm going to factorise this. So I'm going to pull out a 2. So 2 bracket sine squared plus cos squared x, or sine squared x plus cos squared x. Now, using this trig identity here, I know that this bit comes to 1. So basically, I'm doing 2 times 1, and that's going to give me the right-hand side, which is 2. And that's me. I've proven that works. I messed about with it a wee bit by factorising, by substitution, and then I got my right-hand side. Okay, let's look at another one. So, prove that 3 sine squared x plus 1 is equal to 4 minus 3 cos squared x. So I'm going to write out the left-hand side, and then I'm going to think, right, what could I do here? Now, I am noticing there's a cos squared x and not a sine squared x. So I'm going to use one of the arrangements to try and get me a cos squared x. Now I know that sine squared x is equal to 1 minus cos squared x from the previous screen. So I'm going to substitute that in the bracket. And the reason I'm doing that, again, I'll try and get you to think about how my brain's working. I'm looking at the other side here and seeing this cos and no sine. And that was a way of me getting that. I'm then going to multiply out the bracket, so because that seems about the right thing to do here. So 3 times 1 is 3. And 3 times cos squared x is 3 cos squared x. And then the 1's not been affected by the 3, so I'll put a plus 1 there. I'm then going to collect terms up. So 3 add 1 makes 4. So 4 minus 3 cos squared x. I'm going to glance up, and I've worked the right-hand side out. That's worked for me. That's good. Now, these are quite tricky, but they're also quite satisfying if you get it right. But let's have a look at the next one. Right, this is quite a tricky one, this one, right? So let's have a look at it. So we've got the left-hand side is double brackets, right? Let's write that out. Now, when you've got double brackets, then what you tend to do is multiply it out just as you do with algebra. So if you're multiplying out double brackets, you tend to do this, don't you? Sine times sine, and then sine times cos. Well, let's look at that bit first, because sine x times sine x, well, that's sine squared x. And then sine x times cos x is sine x cos x. Just put them next to each other. And there's a takeaway there, so it would be negative sine x cos x. That's you done that bit. And you would then move generally on to multiplying everything by the cos x, but it's a negative cos x. I would do that times that, and that times that. So it's negative cos x times sine x. Well, that will be negative cos x sine x, or negative sine x cos x. It doesn't really matter which way around you put them. And negative cos x times negative cos x. Well, that's plus cos squared x. So notice this one came to be negative cos x sine x, but I just switched it so it looked exactly like this one. So these are kind of the same things now, aren't they? These bits here. Okay, now I'm noticing even though these are split apart, I've got a sine squared x, sorry, plus a cos squared x. I know they're separated here, but I am noticing that, and I know they come to 1. Okay, so You could write them next to each other, and you could, well, what have you got? Negative sine x cos x, negative sine x cos x. Well, that's negative 2 sine x cos x. And again, I know that comes to 1, so I know that's going to be that. And then I've got my right hand side. Okay, I would try and practice that one again, and maybe pause the video and have a go at that one yourself. Right, last one to look at. Prove that tan x cos x is equal to sine x. So the left hand side is tan x cos x. We've got that written out, and I'm trying to get sine x. Now I'm noticing there's no tan x in the right hand side, so I'm going to substitute in sine over cos, sine x over cos x. So notice I've just substituted that in there. And then what I can do here is, because I'm multiplying by cos x and dividing by cos x, they will cancel out, because multiplying and dividing by something are opposites. So I'm just going to be left with sine x, and I've got my right hand side. Actually, I think I've got one more to do. Yep, I've got one more here that I'll go over. Right, this again looks quite tricky and quite daunting, but let's start with the left hand side. So cos over sine plus sine over cos. Okay, now the first thing I'm going to do here is I'm going to look at this, and I'm going to put them together. What I mean by that is I'm going to get a common denominator. So I'm going to multiply this side by cos x on the top and the bottom, and you'll get that. To make a common denominator, you've got to times across by cos x on the top and the bottom. And I'm going to do the same to the other side. I'm going to times this side by sine x, top and bottom, to get me a common denominator. The reason I did that is because the fraction over here is just a single fraction. There's no add that's in it, so I must have to add the two things together. And generally when you're adding fractions with different denominators like 3 and 4, you get a common denominator. And quite often, to get a common denominator, you multiply the denominators together. And that's because it's happened here. I've times by cos x, but you need to do the same to the top. I've times by sine x, to do the same to the top. Now I can write them all over the same denominator, which is kind of more like what the right hand side looks like. Now we're nearly there at this point, because I've got a cos squared x and a sine squared x, which is basically this. I know it's the different way around, but it basically comes to 1. And there I have my right hand side.